In a previous lesson, we did absolute value equations. So now we're going to talk about absolute value inequalities. When we talk about this, we need to remember what absolute value means. So absolute value, remember, means how far something is away from zero. Or another way of looking at it is how far away something is from the starting point. Well, what we did look at last time is we said, okay, absolute value, all right? The absolute value of a number could be of positive 7 here is 7. It means it's 7 places away from 0. Well, it also means that the absolute value of negative 7 is equal to 7. Negative 7 is also 7 places away from 0. So if I were to graph this, I could look at this and I could say, okay, if I start from 0, I could go over to negative 7, or I could go to positive 7. And either one of those describe 7 places from 0. So what we decided is, if I wanted to know what number is 7 places away from 0, that I could set that value equal to either the positive version, or I could set it equal to the negative version. So x could either be positive 7 or x could be negative 7 when I plug it in here. Okay? And the reason we did that is so that when we solve other equations, we can set it to the positive value or the negative value to make it true. Well, what if x isn't equal to 7, but what if x is less than 7? Well, this says now that the distance a number is from 0 has to be less than 7 places. Has to be less than 7 places. Well, let's see. When it was equal to 0, or I'm sorry, when it was equal to 7, that meant it could have been here, or it could have been here. But now in this one, what it says is the spaces away from 0 have to be less than 7. It has to be less than 7. Well, that means it can go anywhere between 7 and negative 7. Right? If you think about this, it could say, all right, x has to be less than 7 places away from 0. But at the same time, it has to be more than negative 7, right? So really what happens here is it has to be somewhere between 0 and 7 and 0 and negative 7. Well, this is described with this. Okay? So the absolute value of x, which is less than 7, okay, has to be more than negative 7, but less than 7. It has to be between those 2 points. Okay, well, hopefully that makes some sense. And again, I find that this tends to be a lot easier is if you stop and you think about what does absolute value actually mean. And if you think about that, it means the distance it is away from the starting point. I think it makes it a lot easier. So if you look at this and you say, okay, the distance that this thing is from 0 has to be less than 7 spaces. So I have to take something less than 7 spaces. Okay, so it's kind of like a yard. You know, if you say, okay, here I'm in the middle of my yard. This is one edge of my yard. This is the other edge of my yard. Okay, I'm standing in the middle of my room. This is the one wall, and this is the other edge of the other wall, and I can go anywhere inside there. Okay. Well, let's take a look at another one. What if x is greater than 7? What if I want to know the absolute value of something that's more than 7? Well, this looks at it again the same way. Again, absolute value means how far it is from 0. And so what I'm saying here is the distance away from 0 has to be more than 7. So if we start at 7, it has to be more than it. So it has to be spaces above it. Or it has to be starting at negative 7, right? Because this is 7 away from 0 in the other direction. And it has to be lower than that. Okay? And really what this does is it turns itself into a compound inequality. When it's greater than this, it becomes an OR inequality. This means that x can be greater than 7, or x has to be less than negative 7. Because both of these things describe distances that are more than 7 places away from 0. Okay? And if you looked at the previous one, if we go back to this previous one, when it was less than, okay, when my absolute value was less than a value, less than some number, it turned into an and compound inequality. Okay? So it's sort of another way of writing these. Let's go ahead and take a look at another one. This is saying the absolute value of some number plus 2, once I find that, that distance has to be less than or equal to 5. Okay, so if I started at 0 here, okay, I would say it has to be less than or equal to 5. I'm going to use a closed dot right there. Okay, which that also means it has to be inside of there. So it's going to have to be confined inside of this area here. Okay, that's what x plus 2 is. So what we can do is we can say, all right, x plus 2 is less than 5, and x plus 2 has to be greater than or equal to negative 5. And now what I can do is I can solve this. Okay, and another way I could have done this, I could have said, okay, x plus 2 is less than or equal to 5, or it has to be greater than or equal to negative 5, right? It's a compound inequality. It's an and statement. I can put it all together as one. So I'm going to solve it this way. I like things when they're a little more efficient, when I can solve multiple things at the same time. I will usually choose to do that. So let's go ahead and I'm going to subtract 2 here, subtract 2 here, which means I also have to subtract 2 here. And I'm going to get negative 7 is less than or equal to x, which is less than or equal to 3. And really what that does is it's just saying you have to take this line here and shift it 2 to the left. Okay? And hopefully this will make a little more sense, having looked at the absolute value graphs and how you can manipulate the graphs based on the way that the equation looks. And hopefully that will make sense, having gone through that activity. All right, so this is what the graph of x plus 2, or the absolute value of x plus 2 is less than or equal to 5. All right, let's take a look at one more. Again, what you want to do here is you want to isolate the absolute value first. You want to get to the absolute value by itself first. So the first thing I'm going to do is I'm going to subtract 3 here, so that I get 2 is greater than, or 2 times 3x minus 5. The absolute value of that is greater than or equal to how about 14? Then I'm going to divide by 2. So what I have here is 3x minus 5. That distance has to be greater than or equal to 7. Okay, so it has to be greater than or equal to 7. So I'm going to start at 7, and the value has to be greater than that. Okay, oops, that would be a filled in circle. Or negative 7. Okay, and I'm just drawing this. I'm not done yet. This is just what my absolute value is saying. I'm just graphing it so that I can look and I say, this must be an or. Okay, so I have 3x minus 5 is greater than or equal to 7. Or 3x minus 5 is less than or equal to negative 7. Solve. Add 5, add 5. 3x is greater than or equal to 12. X is greater than or equal to 4. Or add 5, add 5. 3x less than or equal to negative 2 divided by 3, negative 2/3. Okay, so or now I'm going to go ahead and erase this. I was just using this as a way of seeing if it was going to be an and statement or an or statement, and I found that it's an or statement. Okay, so we're looking at any number. The distance has to be greater than or equal to 4. Or less than or equal to negative 2/3. Well, negative 2/3, let's see, if I go in between 0 and 1 here, and if I kind of separate that into thirds, it would be about here. And I'm going to shade this way. Okay. Now again, what I did in the beginning there is once I got to this step here, okay, I looked and I said, is that going to be an and or an or? And I just quickly graphed it so that I could look and say, okay, that has to be an or statement. So then I can actually fill it in with this. Okay, why don't you go ahead, take a couple minutes, try solving these and graphing your solutions. Pause the video, and then when you are done, go ahead, unpause the video, play again, and we can. I'll have the solutions up here for you. Okay, go ahead, pause. So I've solved the problems here for you. The very first one here, once you subtract 4, you end up with a negative number on the other side. And once you do that, you divide by 2. You still end up with a negative number. And so you end up with no solution because you cannot get an absolute value that's going to be less than negative 1. You can't get it to be equal to negative 1 either. You can't have it to be any negative number. So that's why that one ends up with no solution. And the second one here, I added 7. Got negative 3, and then I divided by negative 3, and when I did that, I had to be careful but to make sure that I reverse my symbol. Once I do that, I realize that the absolute value has to be less than, so the distance has to be less than 1 away from 0. So that means it has to be between 1 here and negative 1. And once I do that, that's my compound and inequality. I subtracted 2, and so I know that n has to be somewhere between negative 3 and negative 1, and that's shown by this graph down here at the bottom. All right, well, why don't you go ahead and practice some more. Here's page 401 to 403, 3 to 19. That should say 3 to 19 all. Apologize about that. So 3 to 19 all. Let's go ahead and fix that for you. So go ahead and work on those, and then when we get to class on the next day, we will go ahead and give you time to work on that along with some of the word problems as well, and discuss with some of your classmates. So hopefully it made sense. If you have any questions, please post comments onto the section below the video, and hopefully we can answer those. Again, sorry, this is still wrong. Let me fix that again. You need to stop talking and writing at the same time. It's supposed to be odd, just the odd problems here. You don't need to do more than that. Okay, go to it, and good luck.